There is a woman buried underneath the foundation of modern mathematics. Her name was never put on the theorems. Her city was burned. Her body was destroyed. And the men who came after her, the Europeans who inherited her work through translation, through theft, through centuries of strategic forgetting, those men received the credit, the statues, the legacy. But the truth does not stay buried forever. An African woman, born in Alexandria in 360 AD, developed the mathematical and astronomical frameworks that Isaac Newton and Gottfried Wilhelm Leibniz would later receive worldwide acclaim for constructing, 12 centuries after she was already dead. Her name was Hypatia. And Rome murdered her in 415 AD to silence what she represented, African intellectual supremacy at the center of the known world, held in the hands of a woman they could not control. Alexandria was not a peripheral city. Understand that clearly before we go any further. In the 4th century AD, Alexandria, Egypt was the intellectual capital of the entire civilized world. It sat on the northern edge of the African continent, where the Nile Delta meets the Mediterranean Sea, and it functioned as the brain of an empire. The Library of Alexandria, at its height, housed somewhere between 400,000 and 700,000 scrolls, original manuscripts, translations, mathematical treatises, astronomical observations, philosophical dialogues, medical records, and engineering blueprints gathered from every known civilization on Earth. Greece, Persia, Babylon, India, Nubia, Carthage, their knowledge converged here. This was not ancient mythology. This was the most sophisticated information infrastructure that had ever been assembled by human hands anywhere on the planet. Into this world, in approximately 360 AD, Hypatia was born. Her father was Theon of Alexandria, not a minor scholar, but the last known director of the Museum of Alexandria, the academic institution attached to the library. Theon was himself a mathematician and astronomer of considerable reputation. He produced one of the most important surviving editions of Euclid's Elements, the foundational text of geometry that would later travel through Arabic translation into medieval Europe and form the basis of Western mathematical education for over 1,000 years. Theon understood what he had in his daughter. He trained her with the full resources of the library behind him, in mathematics, astronomy, philosophy, and rhetoric. By her 20s, Hypatia had already exceeded what her father could teach her. By 30, she was the one doing the teaching. She lectured publicly. This is documented. Students traveled from across the Roman Empire, from Constantinople, from Rome itself, from Athens, from Cyrene, to sit at her feet in Alexandria and receive instruction in subjects that no other living person could teach with her depth or clarity. She taught Platonic philosophy, yes, but more critically, she taught advanced mathematics. Conic sections, the mathematical study of curves produced by slicing a cone, which forms the foundation of orbital mechanics, lens design, architectural load distribution, and eventually, calculus. She taught Diophantine algebra, working directly with the text of Diophantus of Alexandria in ways that extended and clarified his methods for solving what we now call indeterminate equations, the direct intellectual ancestors of modern number theory and algebraic systems. She co-authored, with her father, a commentary on Ptolemy's Almagest, the definitive astronomical text of the ancient world, explaining the mathematics of planetary motion with a precision that would not be matched in Europe until Copernicus, nearly 11 centuries later. Among her documented students was Synesius of Cyrene, who became a bishop and whose letters to Hypatia, 7 of which survive to this day, describe her inventing specific scientific instruments. He credits her with designing an improved astrolabe, a device for measuring celestial positions with accuracy, and a hydrometer, an instrument for measuring the specific gravity of liquids, which has direct applications in chemistry, engineering, and medical diagnostics. These are not disputed. These are recorded in primary sources that survived the burning. Which means everything that was burned contained more. Now understand the political architecture that surrounded her. By 415 AD, Alexandria was administratively part of the Eastern Roman Empire, governed by a Roman prefect named Orestes. The Christian church in Alexandria was led by Cyril, a bishop of enormous political ambition who would later be canonized as a saint, yes, a saint, by both the Catholic and Eastern Orthodox churches. Orestes and Cyril were in open conflict. The city was fracturing along religious and political lines. Hypatia was a Neoplatonist philosopher who believed in rational inquiry, in mathematical truth, in the power of the human mind to understand the cosmos without the mediation of religious authority. She was a close advisor to Orestes. She was, to Cyril's faction, a dangerous symbol, a pagan intellectual woman with political influence, loved by thousands, untouchable in her reputation, proof that the old African intellectual tradition of Alexandria was still alive and still powerful. In March of 415 AD, a mob, documented by historical sources including Socrates Scholasticus, a church historian writing within living memory of the event, attacked Hypatia's chariot in the streets of Alexandria. They dragged her out. They pulled her into a church called Caesareum. And there they killed her. The ancient sources describe them stripping her flesh with roof tiles or oyster shells, burning the pieces of her body, and scattering the ashes. They did not just murder a woman. They performed an annihilation. They were trying to destroy the idea of her, the legacy of her, the very concept that an African woman could represent the highest achievement of human intellectual civilization. Now let us talk about what that destruction actually cost the world, because this is where history becomes economics, and economics becomes power. In 415 AD, Alexandria was still one of the wealthiest cities on earth. Roman Egypt generated approximately one-third of the entire grain supply for the Roman Empire. The trade volume flowing through Alexandria's harbor, spices from India and Arabia, gold from sub-Saharan Africa through Nubian trade routes, silk from China through the Silk Road connections, papyrus, glass, linen, was estimated by contemporary Roman tax records at a scale that dwarfed any European city. Rome's grain dole, which fed the city of Rome itself, depended directly on Egyptian production. African agricultural and commercial output was, in literal economic terms, the foundation upon which Roman civilization rested. The Roman army stationed in Egypt at this time numbered roughly 20,000 to 25,000 soldiers, a massive occupying force, because Rome understood that losing Egypt meant losing the food supply that kept its armies fed and its capital stable. They did not occupy Egypt out of benevolence. They occupied it because it was the most economically valuable territory in their empire. And within that territory, Alexandria was the crown jewel, a city of approximately 500,000 people, one of the largest urban centers on the planet, processing commerce and knowledge in proportions that no European city would approach for 1,000 years. When Hypatia was murdered, the intellectual climate of Alexandria collapsed rapidly. This is not conjecture. This is documented. Scholars stopped coming. The open public lecture tradition she had embodied became dangerous. The church consolidated control over what could be said, taught, and written. Within a generation, the knowledge infrastructure that had made Alexandria the intellectual capital of the world began to transfer, through Arab scholars who recognized its value, through Byzantine translators who preserved fragments, into a form that would eventually re-enter Europe during the Islamic Golden Age, through scholars like Al-Khwarizmi, whose name gives us the word algorithm, and whose mathematical work in 9th century Baghdad was built directly on the Alexandrian tradition that Hypatia had represented. When Leibniz published his calculus in 1684 and Newton published his Principia in 1687,